Now let's take a look at another series where I have to find out the sum of 1 square C1 plus 2 square C2 plus 3 square C3 until n square Cn, that is the sum of R square Cr. Again, we can use both the methods to find out this sum. We will start with the first method, which is the formula method. Now we know that R times nCr equals n times n minus 1 Cr minus 1. Another extension of this formula we learned was R times R minus 1 nCr equals n times n minus 1 n minus 2 Cr minus 2. Now for the successful application of this formula, I have to somehow convert this R square into R times R minus 1. It turns out doing this is quite easy. All I have to do is add and subtract 1 from one of these r's. That would give me summation r square cr equals summation r minus 1 plus 1 into r cr. And then I can break this series across this plus sign to get summation of r minus 1 rcr plus summation of rcr. Here r varies from 1 to n, and here r would again vary from 1 to n, but for r equals 1, this term would be 0. Hence, it's safe to say that r would vary from 2 to n. I can apply formula 2 to the first term to get n times n minus 1 summation n minus 2 Cr minus 2, r varying from 2 to n. Notice I can take n times n minus 1 out of the summation sign because it is independent of r. Similarly, I can apply the first formula for the second term to get n times summation n minus 1 Cr minus 1, r varying from 1 to n. This term is the sum of the binomial coefficients where n equals n minus 2, hence it would be equal to n times n minus 1 multiplied by 2 to the power n minus 2. Whereas this term is the sum of the binomial coefficients when n equals n minus 1. Hence, this term would be equal to n times 2 to the power n minus 1. Solving this further, I get n plus 1 times n times 2 to the power n minus 2 as my answer. Now let's try to solve the same question using the calculus method. We will again start with the expansion of 1 plus x to the power n and then differentiate it once with respect to x. To get n times 1 plus x whole to the power n minus 1 equals c1 plus 2c2x plus 3c3x square until n times cn x to the power n minus 1. Now note here that if I differentiate with x one more time, I would get 2 times 1 in this place, 3 times 2 in this place, and so on. Whereas my objective is to get 2 square, 3 square, 4 square, and so on. An ideal case would be when this x instead of being x is x square, this x square instead of being x square is x cube, so that I can get 2 square and 3 square out here. So let's do one thing, let's multiply both sides with x. I would get n times x 1 plus x to the power n minus 1 equals c1x plus 2c2x square plus 3c3x cube and so on until ncn x to the power n. Now I can differentiate both sides with x again. In the left hand side, I can take n common outside and I would get 1 plus x to the power n minus 1 plus n minus 1 times x into 1 plus x to the power n minus 2. Again, if you are not very familiar with differentiation now, this might seem very complicated, but trust me, this is very trivial once you have your hands on differentiation. My right hand side would become c1 plus 2 square c2x plus 3 square c3x square and so on until n square cn x to the power n minus 1. I can put x equals to 1 on both the sides to get n times 2 to the power n minus 1 plus n minus 1 times 2 to the power n minus 2 equals c1 plus 2 square c2 plus 3 square c3 and so on until n square cn. Note that the right hand side is my required sum. Solving this further, I get n times n plus 1 times 2 to the power n minus 2 as my answer. On this note, let's have a quiz. What is the sum of 1 cube C1 plus 2 cube C2 plus 3 cube C3 until n cubes Cn? Your options are the following.